Welcome you all to the session on solutions of strength of material set 1, that is forenoon civil engineering gate 2022. The subject is, as I told you, strength of material. Going on to the first question of strength of material. The hoop stress at a point on the surface of thin cylinder pressure vessel is computed to be 30 megapascal. The value of maximum shear stress at this point is A 7.5 megapascal, B 15 megapascal, C 30 megapascal, D 22.5 megapascal. Solution for the question: he has given thin cylinder pressure vessel computed with 30 megapascal pressure. So first, when I talk about hoop stress, sigma h, formula is PD by 2T. P represents the pressure, D is the diameter, T is the thickness, given as 30 megapascal. So when I consider case 1, that is maximum shear stress, tau max in the plane is given as tau max is equal to sigma h minus sigma L by 2, that is hoop stress minus longitudinal stress by 2. See, when I talk about hoop stress, this is PD by 2T, and when we talk about longitudinal, it's PD by 4T. Substituting, tau max is equal to PD by 2T minus PD by 4T by 2. On solving, you will be getting around PD by 80, or few times you can directly remember this maximum shear stress tau max is PD by 80. So now we will be taking in the plane direction, that is tau max is equal to 1 by 4 into, I'll write it as PD by 2T. What is PD by 2T given? It is given as 30 megapascal, that is tau max is equal to 1 by 4. PD by 2T is around 30. On solving, you will be getting around 7.5 megapascal. 7.5 megapascal. And when I consider case 2, that is absolute maximum shear stress, tau max absolute, we write it as sigma h minus 0 by 2, that is PD by 2T minus 0 by 2, that is 1 by 2 times PD by 2T. That will give you 1 by 2 into 30, which is 15 megapascal. 15 megapascal. Here in this question, he didn't mention that which value of maximum shear stress is asked. Generally, what happened? Maximum shear stress plane and absolute. We will be considering maximum shear stress on the plane. 99.9% the answer should be 7.5 megapascal, but in the question shear stress at the point, is it plane or absolute, is didn't mention it, so that the answer could be A or B, that is option A or B. Okay, but from the examiner point of view, most probably the maximum shear stress at the point will be the plain condition which is taken into consideration, 7.5 megapascal will be the appropriate right answer, but this is to be counter checked with the solution or the key given by the gate examination. So as of now, hoop stress 30 megapascal given, we have found out tau max in the plane and tau max in the absolute direction. So first case is 7.5 megapascal, second case is 15 megapascal. Moving on to the next question. Consider the cross section of beam made up of thin uniform element having thickness T very far less than A shown in the figure. The XY coordinates of the point along the center line of the cross section is given in the figure. So he has given a T shape like condition here, a web and flange with some distance of 2A and A. The axis is taken as Y and X here. Thickness is T, height is 3A, coordinates K is A comma 3A, minus 2A comma 3A is H coordinate, J is 0 comma 0. Basically, he is asking you the center line of the cross section of the given figure, coordinates of point A, x equal to 0 and y equal to 3A, B, x equal to 2A, y equal to 2A, C, x equal to minus A, y equal to 2A, D, x equal to minus 2A, y equal to A. Students, one thing you need to understand here, shear center of section consisting of two intersecting narrow rectangles always lie at the intersection point of center lines of two rectangles, right? That is nothing but, for example, some cross section like this is being taken. Something like this. G may be somewhere here, but the shear center will be at the point here, right? Or simple figures like two rectangles. If you take S and G both lie at the same point. S and G both lie at the same point. Where S is the shear center and G is the center of gravity, right? In this question, he has given this will be the point where the shear center will be lying. The question diagram has been clearly given to you with two rectangles there. So when I talk about the shear center here, the x direction, the same plane, this is the xy plane, so 0, and in y direction absolutely it is 3a because the height is given as 3a given to you in the question. Without any doubts, we can go with x equal to 0 and y is equal to 3a, a basic fundamental question for 1 mark from shear center. So option A will be the right answer for the given question. A will be the right answer where he is asking you to find out the coordinates of the point along the center line of the cross section, or center line at the intersection point of two rectangles it will be formed. 0, 3a will be the right answer for the given question. Moving to the next question. Question number 3. A horizontal force of P kilonewton is applied to a homogeneous body of weight 2.5 kilonewton as shown in the figure. The coefficient of friction between the body and the floor is 0.3. Which of the following statements is correct or are correct? It may be a two options may be right here, or three also may be right, or only one. Okay. So obviously in the question he has given a rectangular block like thing. 1 meter is the width, 2 meter is the depth or height. P is the force which is applied. Option A, the motion of the body will occur by overturning. Option B, sliding by the body never occurs. C, no motion occurs for P less than or equal to 6 kilonewton. Option D, the motion of the body will occur by sliding only. Now, first of all, by taking some x and y direction, I want to draw some free body like thing. This is the block given to you. There is some force P which is being applied. The width is around 1 meter. Depth is 2 meter. CG will be at the center, the weight force acting downward. This distance will be around 0.5 meter to the CG, right? And the force is applied in this direction, so the friction will be in this direction and the normal force will be acting upward. So motion of the block will occur in two ways. The block may slide to the left or it may tip from a point O, that is this point which I am marking it as O. So first I'll take case 1 into consideration. Checking motion of the block in sliding condition. Whenever we talk in case of sliding, we take sum of forces or summation of forces in x direction is 0. P force acting towards left and the friction force acting towards the right will be equal to 0. So the force which is being applied will be equal to the friction force. This is at summation Fx equal to 0. Now, when we take summation Fy is equal to 0, that are reaction force acting upward and the weight force acting downward, N minus W will be is equal to 0. N equal to W, that will be 25 kilonewton. That will be 25 kilonewton. So friction force is mu n, 0.3 is mu into n is 25. That is 0.3 he has clearly mentioned in the question, and 25 is the weight force which will be is equal to your reaction force. So on solving you will get around 7.5 kilonewton, right? So whenever the body is sliding, this will be the result. Now case 2 I'll take. Checking for the motion of the block against overturning. When we talk in case of overturning, first of all I'll take moment about O should be equal to 0. So when I talk about the moment here, force into perpendicular distance, P force is making with a distance of 2 in the anti-clockwise direction. W weight with a distance of 0.5 is doing it in the clockwise direction. That is minus P into 2 is equal to minus W into 0.5, or one more thing I can write. Minus P into 2 plus W into 0.5 shall be equal to 0. So 2P is equal to 25 into 0.5. P is equal to 25 into 0.5 by 2, which is 6.25 kilonewton. So block will overturn at 6.25 kilonewton. As it's not mentioned that the load is increasing and all, so obviously no motion will come. Whenever no motion is taken, it will be around P should be less than 6.25 Newton, sorry kilonewton it is, right? Whenever the force is between 6.25 Newton and 7.5 kilonewton, motion of the block will occur by overturning. This is by overturning. Whereas if P is greater than 7.5 kilonewton, motion of the block will occur either by sliding nor overturning, or and overturning can I say. So obviously in the question the motion of the block will occur by overturning, yes, I'll go with this answer. Sliding of the body never occurs. No, it will occur. No motion occurs at P is less than 6 kilonewton or less than equal to 6 kilonewton. The motion of the body will occur by sliding only. No. So option A and C will be the appropriate right answer for the question given here. So these are few questions of strength of material and engineering mechanics from set 1 GATE 2022 civil engineering forenoon paper. Thank you students.